All right, welcome to another deep dive. Today we're tackling white box testing, and we've got this whiteboxtesting.pdf document to guide us. So, uh, think of it like we're taking a really close look, like under a microscope, at how your software actually works.
It is a very focused approach to testing software. You're absolutely right. We're looking at the code itself, not just how it behaves from the outside.
So the document says white box testing is like examining the internal structure, design, and coding. I mean, that sounds pretty in-depth.
Yeah. The idea of white box is that we can see through the walls, so to speak, into the heart of the software. And this is different, right, from like black box testing, where you just look at what goes in and what comes out.
Okay, so with this microscope analogy, black box testing would be like watching a cell react to something, while white box is figuring out all the little bits inside the cell that cause that reaction.
That's a great analogy.
Yeah.
And by looking at the internal logic of the code, white box testing helps developers find and fix problems that they might not even know are there just by using the software.
So what exactly are we looking for when we put the code under the microscope?
Well, the document highlights a few things. One is finding what it calls internal security holes, like weaknesses in the code that someone could exploit.
Oh, that's a bit worrying, kind of like finding a weak spot in a cell wall that lets a virus in.
Exactly. And we need to find and fix those before they can be used against us. Another thing is following how inputs move through the code. It's like tracking how a single molecule moves through a cell, making sure each step happens the way it should.
So making sure, like, if a signal is sent through the code, it gets to where it needs to go and is processed correctly, like no dropped calls within the software.
Exactly. And just like a cell has to create the right outputs when it gets specific inputs, we also make sure the software gives us the right results for any set of inputs.
Okay, I'm getting how detailed this can get, but how do we actually do white box testing? Besides needing a really good metaphorical microscope, I mean.
Well, there's a two-step process outlined in the document. The first step is you actually need to go through the source code. It's like studying a cell's DNA before you start experimenting on it.
Makes sense. You have to understand the plans before you start messing with the building, right?
Right. Then, based on what you learn, you create what are called test cases. These are like experiments designed to check specific functions and possible weaknesses in the code.
So do you have to, like, know every programming language out there to be a tester?
Well, knowing this specific language is helpful, but more important are strong analytical skills. You have to think like the developer. A good tester can figure out the logic behind the code no matter what language it's written in.
Okay, so it's more about problem solving than just knowing a bunch of languages.
Yeah. And of course, spotting those security risks we talked about earlier, that requires a special set of skills. Remember those internal security holes. White box testing is all about making sure the software is strong and can withstand any attacks.
You know, the document has this interesting example using a simple code snippet, a function called prime. It seems like a good way to show how white box testing works in practice.
Yeah, it's a good example. The idea is to check every decision point in the code, those if-then-else statements. And using different inputs like A equals 1, B equals 1, or A equals 1, B equals 3, you can see how the code responds and make sure it's doing what it's supposed to.
It's amazing to think how many different inputs you can test, even with a simple code snippet. White box testing is about making sure everything works no matter what you throw at it.
Exactly. Now, another big part of white box testing is code coverage analysis.
Oh yeah, I was curious about that. Does that mean we need to check every single line of code under the microscope?
That's the general idea. But there are different types of code coverage, like statement coverage, branch coverage, and condition coverage. Each looks at the code in a slightly different way.
So different levels of zoom on our microscope. Tell me more about these coverage types.
Well, statement coverage is the most basic. It just makes sure every line of code is executed at least once during the testing, like a quick check to see that everything is turned on, so to speak.
Okay, so it's like making sure every part of our cell is at least visible under the microscope. What about branch coverage then?
Branch coverage goes a step further. It tests every possible decision path within the code. Think about a navigation app, right? You want to make sure it can handle every possible turn and route to get you to your destination.
Ah, so we're not just checking if the car starts, but seeing how well it handles different roads and conditions.
Precisely. Then you have condition coverage, which looks at every possible outcome for every if statement in the code. Like testing a security system. You try all the codes to make sure it knows the difference between someone who's allowed in and someone who's not.
So, like, if the code says if X is true, then do Y, you have to check what happens when X is true and when X is false.
You got it. We want to make sure the software can handle every situation.
This is getting complex. But I can see why this level of detail is needed, especially with important software like banking apps or medical systems.
Absolutely. And there's even multiple condition coverage, which tests every possible combination of conditions. The goal is to get high code coverage, usually around 80 to 90%, to be confident we've tested thoroughly.
So it's not just about code coverage, though, right? You mentioned things like data flow testing and path coverage earlier.
Right, those are important too. Data flow testing tracks how data moves through the code, making sure it's used and changed correctly along the way.
So, like making sure our cell isn't building up waste products that could cause problems.
Exactly. And then path coverage aims to test all possible ways the code can run. It's like exploring every possible route through a maze.
Wow, it sounds like white box testing requires a lot of exploring and analyzing. You're really diving deep into the code.
Yes, and to help with this, testers use different tools, like those you mentioned earlier, JNet, NUnit, and CPUnit.
Right, those tools. So do they like have little probes and sensors to analyze the code?
Uh-huh. Well, not exactly. But they do help automate and make the testing process much smoother. They can create test cases, analyze code coverage, and even point out areas where there might be problems.
So like having a whole team of lab assistants helping with the analysis.
Yeah, exactly. These tools are super helpful for making sure testing is thorough and efficient, especially when you're working with really big and complicated software systems.
I bet. Doing all of this by hand would be, well, insane.
It would be pretty difficult, that's for sure. All right, so we've talked about what white box testing is and how it's done, but why go through all this trouble? What are the benefits?
Yeah, good question. Why bother looking so closely at the code?
One big advantage is that it helps find hidden errors that might be missed with other testing methods. It's like finding a tiny mistake in a cell's DNA that could cause big problems later on. We want to find those problems before they become serious.
So like catching a disease early when it's easier to treat?
Exactly. And since you can start white box testing early in development, it helps prevent small errors from becoming huge problems.
Makes sense. It's easier to fix a typo in the first draft of a book than to rewrite whole chapters later.
Right. Another advantage is that white box testing can help make the code better. When you know exactly how the code works, you can find ways to make it more efficient, more secure, and just overall better.
So it's not just about finding errors, but also about improving the code itself.
Exactly. It helps us create software that not only works, but works really well.
That's great. But even with all those benefits, there must be some downsides to white box testing, right?
Well, yeah. One challenge is that it can be pretty complex and resource intensive, especially for big software projects.
Mm-hmm.
You need skilled people and a lot of time to do it properly.
I imagine it's like the difference between studying a single cell and mapping the entire human genome. The scale is just different.
Exactly. Another potential problem is what we call developer bias. Since the testers often know the code well, they might miss errors or make assumptions that lead to incomplete testing.
Ah, so like being so focused on one part of a cell that you miss other important details?
That's a good way to think about it. So testers need to be objective and look at the code with fresh eyes, even if they're already familiar with it.
Okay, so it's a powerful tool, but you have to use it carefully.
Exactly. But we've been talking about this from the developer's point of view. What about the everyday user? Why should they care about white box testing?
Yeah, that's a good point. How does all this relate to the person using the software?
It's a really important question because even though most people don't think about it, good white box testing affects everyone who uses software. We'll talk more about that after the break.
Stay with us. Welcome back. So before the break, we were talking about like what happens when white box testing isn't done well enough? What are the risks for us, the users?
It's a crucial thing to consider, and it goes back to those security holes we talked about. Without really analyzing the code, those vulnerabilities can be missed. Like, imagine a banking app that looks secure, but there's a hidden flaw that lets hackers steal your money. That's what can happen if the testing isn't good enough.
Yikes, that's a scary thought. So white box testing is like a safety net, catching those problems before they can cause real damage.
Exactly. Think of it like, a car factory. Before a car leaves the factory, it goes through a ton of inspections, making sure every part is working right. Skipping that process could be disastrous.
Okay, I get it. Testing is important. But let's go back to that code coverage analysis thing. It sounded like there are different levels of coverage, from basic to really detailed.
You're right. It's like adjusting the focus on our microscope, zooming in to see the code from different angles.
So walk me through those different zoom levels. What are the main types of code coverage?
The most basic one is statement coverage. It just makes sure that every line of code runs at least once during testing. It's like a quick scan to make sure everything is there and turned on.
Okay, so like a basic health check for the code. But what if we want to go deeper than just seeing if things are switched on?
Then we move on to branch coverage. This is about testing every possible decision path in the code. Imagine you're using a navigation app. You want to make sure it can handle every turn and every possible route.
Right, so not just does the engine start, but can it drive on different roads and in different conditions?
Exactly. Then you have condition coverage, which focuses on every possible outcome for every if-then-else statement. Like testing a security system, you try every code to see if you can tell the difference between someone who's allowed in and someone who's not.
So if the code says if this, then that, you test what happens when this is true and when this is false.
Yeah, exactly. It's about making sure the software can handle every situation. And then there's multiple condition coverage, where you test every possible combination of conditions. It can get pretty complex.
That's a lot of possibilities. But I can see why it's important, especially for software that deals with important stuff, like banking or health information.
Absolutely. The goal is to reach high code coverage, somewhere between 80 and 90%, to be sure we've tested everything thoroughly. But remember, code coverage analysis is just one technique. We also have data flow testing and path coverage.
Right, those other techniques. Remind me what those are about.
Data flow testing is all about how data moves through the code. It's like tracking a package as it goes through a delivery system, making sure it gets to the right place and doesn't get lost or damaged.
So it's about data integrity, making sure the information doesn't get corrupted or goes missing.
Exactly. And then you have path coverage, which is about testing every possible way the code can execute, like trying every single route through a city.
That sounds incredibly thorough, but I guess that's what you need to make really reliable software.
You got it. And to help with all this, white box testers use tools like those we talked about before, JUnit, NUnit, CPQnit.
Oh yeah, those cool. So they actually have like tiny little robots that crawl through the code and find errors.
Uh-huh. I wish it was that simple. But they do have features that automate a lot of the testing. Things like creating test cases and analyzing code coverage. They can even help find potential problem areas.
So like having a bunch of digital assistants helping the testers do their job.
Right, exactly. They're super helpful for making the testing process much more efficient, especially with those huge, complex software projects.
I can only imagine. So let's talk about those memory leaks again. We compared them to a cell building up waste. Can you explain more about what they are and why they're bad for software?
Sure. A memory leak happens when a program uses memory but doesn't release it when it's done with it. It's like if you went to a restaurant, finished your meal, and then just left without telling anyone you were done. The table would just sit there empty, even though you weren't using it anymore.
Ah, so it's like the software is hoarding memory and eventually it runs out of space and crashes.
That's a good way to think about it.
Yeah.
It's like your computer's hard drive filling up with junk files. White box testing can help find and fix these leaks.
So it's not just about security and making sure the software works, but also about making sure it uses resources well.
Exactly. It's like having a well-organized house. It just runs more smoothly.
Okay, I'm seeing how white box testing affects so many different aspects of software. It's about security, functionality, performance, even the user's experience.
Yeah, it all ties together. And while it might seem like a lot of work up front, in the long run, it saves time, makes users happier, and creates more secure software.
It's like investing in something that's built to last.
Exactly. And as people expect more and more from software, the need for good testing, including white box testing, is only going to become more important.
But let's talk about the people doing the testing for a minute. What kind of skills and mindset do you need to be a good white box tester?
Well, knowing the technical stuff is important, of course, but there are other things that are just as important.
Like what? I'm curious.
The most important thing is a good analytical mind. You need to be able to break down complex systems, understand how they work, and find potential problems.
So like a detective for code?
Yeah, that's a good way to put it. You're looking for clues, figuring out how things connect, and solving the puzzle of how the software works or doesn't work.
Yeah.
You also need to be super detail-oriented, noticing even the smallest things.
So sharp mind and a keen eye. Any other personality traits that would help?
Curiosity is really important. A good tester is always asking why
Hmm.
and what if. They don't just want to know that something works, they want to understand how it works and what could go wrong.
So like those kids who always took apart their toys to see how they worked, but now they're doing it with software.
That's a great analogy. That curiosity is what drives them to really dig into the code and make sure it's working as intended. And of course, you need a passion for quality.
Right, because at the end of the day, white box testing is about making software that people can trust, that's safe, and does what it's supposed to. It's about creating a good experience for the user.
Exactly. And as we depend more and more on software, white box testers are going to play a bigger and bigger role in shaping technology.
Okay, so we've talked about the technical side of white box testing, and now we're seeing how it connects to bigger ideas like trust, security, and the overall quality of the software we use.
And ultimately, it's all about making a safer and more reliable digital world for everyone.
Well said. But before we finish this deep dive, I want to come back to something we talked about before. We've discussed the benefits for developers, companies, even users in general. But what about on a personal level? How can knowing about white box testing benefit you, the individual person using the software?
That's a fantastic question and a perfect way to lead into our final segment. We'll explore how this knowledge can empower you and why it's so important in our digital world.
Stay tuned. We'll be right back. Okay, welcome back for the final part of our deep dive. So we ended on this question. How can understanding white box testing actually help you, the person using the software?
Yeah, it might seem like something developers need to worry about, but knowing a bit about white box testing can make you a smarter software user, especially now that we use apps and websites for just about everything.
It's like, if you know how to read food labels, you can make better choices at the grocery store, right? You don't need to be a nutritionist, but that information helps.
Exactly. In the same way, knowing that a company uses thorough testing, like white box testing, it can give you more confidence in their software.
So it's something to think about when you're choosing between two apps. The one that's been rigorously tested might be the better option.
Absolutely. It shows that the developer cares about quality and security.
Hmm.
And, we give these apps and websites a lot of our personal information, things like our bank details, our messages, even our health data sometimes.
That's true. It's easy to forget how much we rely on software these days. And you really don't want to use a banking app with security flaws or a health app that leaks your data.
Nope, not at all. Knowing a company uses white box testing can give you some peace of mind. They're taking those risks seriously.
So it's really about trust. We're trusting these companies to handle our information responsibly and to create software that's safe and reliable. And white box testing is one way to know if they're doing that.
Exactly. It shows that they're not taking shortcuts.
I have to say, this whole conversation has made me think differently about the software I use every day. I'm going to be reading those privacy policies a lot more carefully now.
That's great. It's all about being a more informed user.
Okay, so we've gone full circle here. We started with the technical details of white box testing, but now we see how it connects to bigger things like trust, security, and the overall quality of the software.
It all comes down to making a safer and more reliable digital world.
Well said. So the next time you download an app or visit a website, remember all the work that went into making it function well and keeping your information safe.
Think about all the tests, all the lines of code that were checked, and the effort that went into creating a good experience for you.
And maybe you'll even want to learn more about the world of software development and how important white box testing is.
It's a fascinating field, and even knowing a little bit can help you be a more confident and informed user.
And that's it for our deep dive into white box testing. We hope you enjoyed it and learned something new.
As always, we encourage you to keep learning and exploring and keep diving deep into the things that interest you.
Until next time.